Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems minimum deletions to make string case specials. Yeah, so this problem act as a medium and I feel so it's an indeed medium. It's a very good problems to solve actually. Yeah, so let's get started on this. So they have given a string word and an integer k. Now we considered word to be case special if so they have given a string of word, right? String word and an integer k. Now we considered word to be case special if frequency of word I and frequency of word j is the absolute of the delta is less than equals to k for all indices I and j in the string. So on the strings that we are going to consider, on the strings, if you can select any indexes and the frequency, the elements present on that index, if you are going to check the frequency of that particular characters throughout the word string given to you, and you can select arbitrarily a j index, and similarly you can check its frequency of the element present on that index, and if the delta of that particular indices, the frequency of that particular indices is less than equals to k for all ij, you can select your ij in any order. If this conditions is going to be satisfied for all the cases, then we can consider it the word is case special. The word is case special for sure. Now here you can see frequency of x denotes the frequency of the frequency of the character x in what I think you guys should know. So the number of times that particular character letter is occurred in the string. So I think it's very straightforward. I guess we all know. And this denotes the absolute differences of y, that is of if something is -2 -3, the absolute of is positive, that is of 2 3. Now return the minimum number of characters you need to delete. So take a note on this. We are only allowed to delete note. We don't have the liberty to add note. We don't have the liberty to add characters. We only have the liberty to delete characters, so that the word is case special. The word is case special. Yes guys, so the problem is on 2 to 3 lines only, and it's very straightforward, I guess. So if you guys are not going to get the gist, I will definitely suggest you to go to the test cases. Please make your patience in a little bit more, so that we after the going to the example test case, you will definitely get the gist. So here you can see, so we have that a b c a b a and k is given as 0. So that means to make its case special, so that means we have to make our word is 0 special. So that means the differences of any two characters you can select, the frequency of that characters is bound to be 0. So that means the frequency of all the characters should be 0. So in this example test case, you can see we can delete word 0. We can make word to be 0 special by deleting 2 occurrences of a, because how many occurrences we have? A of 1 2 3 4. So we delete 2 occurrences of a, so a's frequency becomes 2, right, from 4 to 2, and 1 occurrences of c, and c has only single occurrence. You can delete the single occurrences of c. So therefore our word becomes BA, and the frequency of A and frequency of B is same, and that is of 2, and the delta between them is 0. So we are satisfied. So how many characters we deleted? We deleted 3 characters. So the output is 3. So like this way, the minimum deletions we have to return. On this example test case, you can see we can make it 2 specials by deleting 1 occurrences of A. So that is the single occurrences of A, and 1 occurrences of B. 1 occurrences of B. How many occurrences of B we have? 1 2 3 4 5 occurrences. So B's frequency becomes 4. So that's it, right? Therefore word becomes BDC this something something, where frequency of B is 2, frequency of C is 3, frequency of D is 4, and you can take any two among them. It is always less than equals to k, less than equals to k. So how many characters we have deleted? 2 characters. On this example test case, k is 2, so you can delete only this B. We can make word to be 2, word 2 special by deleting 1 occurrences of B. Therefore word becomes all are A's, and the frequency is now uniformly 6. Yes, for each letters frequency is now uniformly 6. Yes, agree, totally agreeing guys. So now you can see our constant is as big as 10 raised to the power 5, and k is as big as 10 raised to the power 5, and word consists of only lowercase English letters. So we definitely have to think a solutions kind of big of n or big of n log n to get it accepted, right? Because the constant is very high, that is of 10 raised to the power 5. Yeah, so now quickly go to our OneNote. We'll try to build our intuitions. So I think you guys, with the example test case, like take a pause to the video and think on your own if you guys can think of kind of a solution. There are multiple solutions. After submitting my code, I have gone through like multiple kind of solutions. So there are some solutions which are using sorting and hash tables and then countings type of things, which is going to take a kind of lower time complexity which we have written, but I think our code is also indeed most optimized times and most optimized space it is going to be for sure. There is no chance it's going to be take that time. Yeah, so now our solutions is very unique. So I actually like feel to be myself a little bit proud to think on that particular note. It is indeed a like very good solution. So let's suppose what happens. Why it is not writing? Give me 1 minute, guys. What it is doing? Shit. Yes, it's working now. So we have some characters A, B, C, and they have given us a k factor. We have given as a k factor. Let's suppose 3. So they have also given us a k factor. Now, can you guys tell me? What actually we can do here? So to make it 3 special, we have to make it 3 special. So that means the frequency of any characters, the delta between the frequency of any 2 characters should not be exceed of 3. So okay, I am going to state you arbitrarily. Let's try to make your lower bound to be at 0. Then what is the allowed upper bound? Our allowed upper bound is L plus K. So that is nothing but 3. So our allowed upper bound is 3. So I will try to make the frequency of all the characters from 0 to 3. Agree? Then if I am going to try to make, so frequency of A is, so my window is, if I am going to consider my window, so a constant window of L to R, the gap is constant, is always to be K. The sliding window, I will going to put a constant sliding window of size K. My L is going to be at 0. So I will allow to make the frequency in the range of 0 to 3. Okay, let's go ahead, Shouvik. It's pretty interesting now. Pretty interesting till this point. Frequency of A is, I am going to write frequency of A is, oh shit, it's too slow actually. Frequency of A is 2, B is 2, and C is also 2. Let's make it a little bit more interesting. Add a D, right? So A, B, C, D. Agree? A, B, C, D. Frequency of all these are 2 and D has frequency of 1. So I will try to make everyone's frequency in the range of 0 to 3. Okay. Then frequency of A is 2. Is it 0 to 3? Oh, yeah, it's 0 to 3. It's 0 to 3 only. Frequency of B is 2. Is it 0 to 3? Yes, it also. So I don't need to delete at all. So for 0 to 3, how many deletions we have performed? Our result for this. Tell me, our result for this 0. So we have not deleted anyone. So that is the most optimized. Now I am going to slide my window L to be at 1, R to be at 1 plus 3 is 4. Till this point, the deletions is going to be 0 because all are by default satisfying. Now I am again going to slide my window. L to be at 2, R to be at 5. Now D is out of bound. So D has frequency of 1, right? And we are considering the window. Everyone should be in the frequency range of 2 to 5. So one element we found at this particular point. That is of less than L. So if I am going to incorporate him to my window, then my window is going to be invalid. So I have to delete all occurrences of D. So whatever the frequency of D, I am going to delete all. So my result becomes 1. So like this way, I have to shift my window, a k size constant window. I will shift and I am going to validate. For every window. What is the deletions? What is the result I am going to form? What is the minimum deletions I am performing? So now take some of the. So how far you are going to slide your window? How far we are going to slide our window? So can I say it's nothing but the maximum frequency? It's nothing but my maximum frequency. If a particular element has occurred 5 times, so I will start from 0 to my k. First one is 0 to k, second one is 1 to 1 plus k, second one is 2 to 2 plus k. Like this way I will switch. Like this way I will shift my window until what? Until my current window size that we are going to consider, my current window size is less than equals to my maximum frequency, is less than, sorry, what happens? Oh shit, yeah, it's again going to be, it's working, right? Yes, it's working. So I will shift my window, until my right side is less than, that is my right, that is my left, and that is my right. So this is less than equals to my whom? Less than equals to this window, less than equals to my max frequency. Now I will giving you a case where my this allowances of k. So that means if you are 0 to 0 plus k is altogether higher than your max frequency is smaller. So these things is higher. So on that case, do we need to delete anything? Take an example test case. So let's suppose I have this a, b, a, c, and let's suppose our k is given as 10, right? K has given us 10, very high value, right? So consider this example test case. So my max frequency, how many elements we have at max frequency? We have total of 3 elements. So that is my max frequency. So I maybe at very worst case, I am going to delete the max frequency elements completely. So let's suppose my max frequency is 3 and k is given as very high value 10. So that means very intuitively you guys should get the gist. I have to make it 10 special. So that means any two characters. So if my max frequency is 3, let's suppose my mean frequency is 1. So what is the minimum frequency of a character? Is at least 1. And what is the max frequency we have? So the max frequency is 3. So if my max frequency is altogether smaller than my k, so it is indeed as k special. So k special is not forcing you to make it exact k. The condition is less than equals to k. If your given array is already in the given word is already have less than k frequency, the maximum elements occurrence is less than k, do I need to delete anyone? No. If that is the case, then you can return a 0 for straightforward on that particular case. Else the game that we just saw. So now take few of the cases to take a more stronger grip, on this. So I am going to, can we take some example tests, because I'm not sure it's going to be lag at all the times. So we have DA, can I make copy will be not work, DA BD CB, that is quite high. DA BD CB, try to make a copy. And k factor is 2 here, right? Are they allowing me to paste it? Okay, it indeed it allowed. Thanks. So if I can quickly write a clone of it, so what I have at, so DA BD CBD DABD CBD, right? CBD, then CD, then we have CD. Correct. So that is the strings they have given to us. So how many occurrences of D? D's occurrences 1, 2, 3, 4, 5. D 5 times. Eighth occurrences is 1. Only one. Yes. A is only 1. B occurrences of B is 1, 2, 2. Yes, 2. Then C8 occurrences is 1, 2, 3, right? 1, 2, 3. So now put our, now k is also given as 2. We saw it. So now if I am going to put our algo here, we are going to consider a window. So what is the maximum frequency? Here? 5. So is 5 is smaller than my 2? No. Then on that case we have to put our algo. Otherwise, let's suppose our maximum frequency is 1 only. So that means it is already case special. Is 2 only, it's already case special. But here the maximum frequency of a particular character is 5. So we have to build a algo. So now how our algo is going to be work? Our algo is going to consider all of the window of size of size 2. All of the window of size 2. What is the starting point? What is the minimum frequency of a particular characters? What is the minimum frequency? Tell me guys, quickly. So the minimum frequency is going to be a particular character is 0, right? That means that particular character is altogether not encountered, altogether not occurs to my given word. So I am going to consider first window of 0 to 2 side, 0 to 2 side. So for 0 to 2, D is 5. So if I want to bring it in the range of 0 to 2, so how many dth occurrences we have to delete? How many dth occurrences we have to delete? D is 5. We have to try to make it to 2 so that its frequency is in the range of 0 to 2. So 5 minus 2 is 3. So I will delete its 3 occurrences. For A, it's 1. For A, it's 1. So that means it's also out of bound. It also out of bound. No, we are considering 0 to 2, 0 to 2 only, right? So it is inbound. It is inbound. Sorry guys. So it is inbound. 0 to 2. A is within the boundary. B is within the boundary. C, are you within the boundary? No man, you are at 3. So you also have to delete its 1th occurrences. So on this example test case, on this window, how many we have deleted? How many we have deleted? We have deleted 4, right? Now shift our window. Consider window of 1 to 3. 1 to 3. D 5. 5 minus 3 is 2D is going to be deleted. A is 1 within. A is 1 within. B is 2 within. B is 2. B is also within. C is 3. C is 3. Within or not? C is also, I guess, within. So how many we have deleted? We have deleted 2 only. Shift window. How far? Till 5. Till my right pointer is going to be 5 only. Shift 2 to 4. 2 to 4. A out of boundary, man, out of boundary. You are out of boundary. So A is completely deleted. First consider with D. D 1 occurrences, right? A 1 occurrences. BC within. How many we have deleted? 2. How many we have deleted? 2 deletions. Shift window. 3, 5. That is the last shift because we are at max frequency. Our right pointer is at max frequency. D, no deletion. A, 1 deletion. B, 2 deletion. C, no deletion. How many we have deleted? 3. So till this, what is the minimum? In which window we got the minimum? This window and this window. So you can take any of the window, you just have to return the count. So either we are going to consider a window of size 1 to 3. So every number frequency should be in the range of 1 to 3. If it is out of bound, if it is more, then we are going to delete what the delta, how far it's more than my right side. That many we have to delete. If it is less than my left, delete all of its occurrence, because we only have the liberty to deletions. We don't can add to make it equals to L. We don't have the liberty. So delete all of its occurrences. So either 1 to 3 or 2 to 4. Either of them. So on this example test case also, now we can do the code iterations, and also I will go to you the code, this particular example test case. They are deleting the occurrences of A and 1 occurrences of D. So that means frequency of B is 2, frequency of C is 3, frequency of D is 4. So they have considered the window of 2 to 4. So we have found 2 windows, one of 2 to 4, one of 2 to 4, and another one is 1 to 3. Either is fine. They considered this window. Yes, with this also we are able to make answer 2. Yes. That's exactly you have to write to your code format. So now we can do the code iterations for sure. So I have defined my DD maxi default dict to be of int because we need to store the frequency. Maxi to be -1, that is the max frequency. What is the max frequency? I have initialized with -1 and I am iterating for each inwards, and I am build our dictionary, frequency dictionary, and our maxi goes to max of maxi and our DD of each. So that is my maxi is going to be stored the max frequency. Till now we have to encounter our sliding window. A sliding window. Now L and R answer we have initialized L to be 0, R to be at K, answer to be at very high value because we have to minimize it. If our R is altogether higher than my maxi, if the max frequency is smaller, then it is already case special. That particular case return 0. Else I am going to slide my window. R less than equals to my maxi. I will iterate my sliding window to be 1, 1, 1 for, and I am going to increment I am going to consider a window of size L to R. So I've initialized my result to be at 0. So till this particular window, to this particular window, what I can achieve, what is the result I can achieve. So for char in DD, I am iterating to my dictionary, default dictionary that we built. If that particular characters is less than my left, so that means its frequency is less than my lower boundary, so we have to delete all of its occurrences. So result plus equals to DD of character. So whatever the frequency of this particular character, we are deleting all of its. If this particular characters is more than my right, so then delete how far it's right. So result plus equals to DD of character minus right. That's it. So we are going to get this particular left and right, this particular sliding window. What is the answer you are able to build? And you are minimize it to your result. You are minimize your answer and result, and you are moving your window. To L plus equals to 1, R plus equals to 1. So that we are always to be maintaining a window of K. Because we have initialized with L to be 0, R to be K. So we have initialized it to be of K size window, and we are sliding it plus 1 like this. So this is a ideal solutions of a fixed size sliding window. So now we can quickly discuss the time complexity of this particular code. I think you guys should predict on your own. So the time complexity, here we are building our default dict. It is of big of n. This particular while loops is going to be take of what? Big of n only. That is the maximum frequency of a particular characters would have. So first big of n, then plus big of n, and this for loop can grow as big as 26 only, because that is the occurrences of, because all the characters are in lowercase English letters. How many we have in lowercase English letter? 26 only distinct. So we are iterating on key of the dictionary. So on dictionary's maximum size can as big as big of 26. So this for loop is iterating as big as 26 only. So that is the game, that is the beauty, guys. So when there is a lowercase English letter question you are going to face on any interview, on your future online assessment, anywhere, try to put this big of 26 for loop. It is going to be 100% or 99% cases it is going to be set on that particular question. So this iterations is going to be a big O of 26. So I can write it in big O terms. It is of big O of 26 n plus n. So it is of big O of 27 n solution. And on space perspective, do you guys see we are using space? Yes, man, we are using default dict. We are using, and each size is can big as big of 26 only, because 26 distinct characters in lowercase English letters. Yes, agree. So that is one of the most optimized time and space complexity you can achieve for this particular problems. But I have gone through with the discuss forums after my code submissions, and I found some of the code is going to be a take of big O of 3n, 2n kind of solutions. That is a kind of most optimized versions of it, you can say, but the readability is kind of a compromise that. So that's the reasons I put it this particular solutions in, and it is indeed to be, you are going to get a on blind submissions you are going to get an AC. There should not be any case where it is going to give you a TL, because it is a big of n kind of solution. 27, 26, these are constant factors on. So it is perfectly work to your interview perspective on also. So yes, guys, so this is the most optimized time and space complexity that I am able to think of, and I have tried my best to explain to you guys. And if you guys are able to understand till this point, I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product-based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another video question. Bye, guys. Bye.